Hi folks, Mr. Long here. We are going to use a pattern-based strategy to solve quadratic equations in vertex form. Just to begin, let's take a look at some simple cases for the simplest of quadratics, really, y equals x squared and y equals 2x squared. So we know that a 1 square, when it goes over in the graph, this location right here is the vertex, of course. And as the graph goes over by 1 to the right, it will go up by 1 squared, of course, which is 1. Similarly, if I look at the vertex here, and I've now got a 2 square, so a 2 by 2 square, that area would be 4. So 2 squared is 4. So if you're noticing a pattern, the rise, and in these cases right here, the rise and the run, how are they related? Well, how are 1 and 1 related? Well, it could be multiplied by 1, but it also could be another rule. How are 4 and 2 related? Well, if we think of this from an inverse operation perspective, if this is 1 squared, the relationship here would be the square root. So the square root of 1 is 1. The square root of 4 is 2. Similarly, if we know the rise is 16, what is the run? Going away from the vertex for y equals x squared. Well, it would be square root of 16 equals 4. So when there is a run of 4 away from the vertex, there will be a rise of 16. Okay, folks? So it's just the square root being the inverse of squaring. So now what happens if we change it to 2x squared? Well, you have twice as many squares growing. You have 2 growing squares now. So the area of 1 square is 1. The area of 2 squares is 2 times 1. The area here, a 2 by 2 square for this one is 4. So it's going to be 2 times 4, which is going to be 8. So now if we look at it from the other perspective, what I need to do first is, if I know this is 2x squared, and I know that my rise is 50 and I'm trying to figure out my run, I know the first thing I'm going to have to do is to divide by the a value of 2 to get 25. Because here I would need to divide by 2 to get 4. Here I'd need to divide by 2 to get 1. Okay, so then I've got 25, and then down here it will be the square root of 25 equals 5. So that's the way that that you do it when a is not equal to 1. So it's just getting that slope relationship between rise and run for a parabola moving away from the vertex. So you might want to pause it now and take a look at what we looked at there. This is really just prior knowledge on how you're going to use a strategy to solve an equation. So let's move to the next screen. And in the next screen we're actually going to solve this equation here, 2 bracket x minus 4 quantity squared plus 1 equals 73. So when I look at the parabola, I know my vertex is going to be given by 4 and 1. So an x value of 4, a y value of 1. That's a positive 2, so it's opening up, so it looks something like that. That's 1/2 of it. And we're just going to begin with half of the parabola, just to help us out. So then how do I solve this equation? I'm looking for when that parabola intersects with the line y equals 73, of course. Well, let's see if we can do something here. I know that the height of this slope triangle, the rise, if you will, is 73 here. Take away the 1 here, because that's 73. So the rise is the difference between 1 and 73, which is 72. I know there's an a value of 2. So I've got to divide that by 2 to get 36, and that now I've got it back into the basic x squared pattern, and square root of 36 is 6. So I know that this value here is 4 plus 6, so that will be 10. Going in this direction, I have to move 6 over this way, of course, as well. 4 take away 6 is negative 2. So it will cross right here at negative 2. So what are the solutions to this equation? X equals negative 2, x equals 10. And that's just through pattern recognition without any inverse operations. Although what I just did there is exactly what the inverse operations are. So for example, I took, if you want to really think about it this way, what are the operations that I did? Well, the first thing I did was I took 73 minus 1. And the second thing I did was to divide by 2. I took the 72 that was left and I divided by 2. And then the third thing I did was square rooted 36. And the final thing I did was to add 4. So if you look at it from an inverse operations perspective, we can see that the opposite of the plus 1 here is the minus 1 here. The opposite of the multiply by 2 here is the divide by 2 here. The opposite of the squaring here is the square root here. The opposite of the minus 4 here is the plus 4 here. So in fact, when we do it graphically through patterns, we are just following the inverse operations. So they are, the inverse operations are very much connected to doing this through a sort of analytic geometry reasoning strategy.